We're starting Module 4, Topic 1. So many numbers, so little time. We have to remember how to make a fraction into a decimal and percent, and decimal into fractional and percent, and a percent into both the fraction and decimal. So in order to start, number 1, 5/8. So we take 5 and we divide it by 8. 8 doesn't go into 5. 8 does go into 50, and it goes in 6 times. I subtract, get 20. 8 goes into 22 times. That's 16. 8 goes into 45 times, and it goes in evenly. So 0.625. And then in order to make a percent, I move my decimal over 2 times. And when I do that, I get 62.5%. Then, again, my decimal is here. If I would divide it by 100. So in order to make 105 into a fraction, I would put it over 100. 5 goes into this 21 times. 5 goes into 120 times. So I have 21 over 20. Now, I could either divide 21 by 20, or you just move your decimal over 2 times and you get 1.05, not percent. Here, in order to make this, I multiply it by 100, and that gets me 55%. And then 55 over 100 will give me my fraction, but I need to simplify that. 5 goes into that 11, 5 goes in there 20 times. So that's how you would find the fractions, decimals, and percents. Okay. List 3 numbers that are positive numbers. Now, it doesn't say whether it wants rational numbers, irrational numbers. It doesn't say it wants integers, whole numbers. So you could put any number you want. You could put 1, 2, 3. That would be fine. But you could also put 0.0342. I don't know. Or you could put 4/5. You could even put pi if you wanted to. You could put the square root of some number, or the square root of this number. It doesn't matter. It just needs to be positive. List numbers that are between 0 and 1, somewhere between 0 and 1. Now, decimals are really easy because as long as there's a 0 out front, you could put any number on the right side of the decimal point. Now, in order to make sure the fraction, if it was to make a fraction, that the numerator, the number on top, is smaller than the number on bottom. So I could pick 47. As long as that number is less than the number on the denominator, you will have a fraction that is between 0 and 1. Percent, 3%, 10%, I don't know, 48%. I'm just picking random numbers, 93%, whatever. Given a fraction, 3/4, -10/11. Doesn't say that it had to be positive. Mixed number, as long as you have a whole number, actually, as long as you have an integer. And then a fraction next to it. Those are mixed numbers. So now we're going to do a sort. It's on page 13. And you do a sort with these numbers. Now, there are some people that decided in class to do positive and negative numbers. Okay, so if I was to do positive, I'm going to go through and circle all the positives. Positive, positive, positive. Now, some of you are going to say on this one, that's a negative. But these bars right here, those are absolute value. It means the distance from 0. So the answer to that is actually 3, because it's 3 away from 0. Positive, 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 positive. Let's see. I feel like I missed a number. Oh, I didn't. You didn't see me do this, by the way. 0 is neither positive nor negative. It is positive nor negative. I cannot believe I just did that. So negative, we did this. Okay, but then you have the number 0. So it's neither positive nor negative. So you could have grouped it like that. That would have been perfectly fine. Now, there are some people that that's not how they did theirs, which is fine, because I prefer you to come up with something that not everybody else has done. So one of my groups said, I want fractions. Okay, so if I go through this, I'm going to get fractions. So fraction, 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 fraction. Okay, so those were my fractions. And then they said decimals. Decimal, 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 because remember, this is 0.2. Decimal, decimal, decimal. This will actually be a decimal because it's not going to come out to be a whole number. Okay, decimal, 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 decimal. This is negative 23, so that will be a decimal. This will be a decimal, and this will be a decimal. Then, oops, I forgot this one. And then what was their other group? I think that they did square roots. Oops, I already did that color. I think they did square roots was the next one. Now, this last group, and actually those two will kind of overlap just because you don't know that yet. This would be an integer, this will. Because we haven't talked about it yet. Okay, so you could do it many different ways, okay? Many different ways. Awesome. So now we're going to look at 1, 2. And here we have this grouping of numbers. And it says, why do you think Lauren put these numbers in the same group? Well, we either need them all as fractions or as decimals so we can tell. I'm actually going to make all of these into decimals so that it's easier to look at. So hopefully you guys know how to divide this one. It should be one of those numbers that you already know. Then we have 100 divided by 11. Okay, 11 doesn't go into 10. It does go into 109 times, so that will get me 99. Oh, look at this. Doesn't go into 10. Bring down a 0. Look at that. It's just going to keep repeating itself. Okay? So this number right here is 9.09, where the 0 and the 9 repeat. Now, if you look at each one of them, look at this. Oh, I should use a different color. Look at this. Repeat, 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 repeat. These are all repeating decimals. Now, okay, Zane and Tanya say that these are both positive integers. Okay, I'm not sure if you remember what an integer is. An integer are negative and positive numbers that don't have fractions and decimals. The real definition is a whole number and its opposite. So, if I was to take the absolute value of -3, I would get 3. What times itself gets 100? 10 does. This is positive. Guys, this one, it has a positive exponent, so that means that this is going to be a big number, but it's going to be a positive number. 4 squared, that's 16, and the distance from 0 to 2 is 2. So yes, all of these are positive integers. Now let's look at Tanya. Tanya is 20%. Well, it's positive, but remember you have to move the decimal over. That's 0.20. That is not an integer. A decimal and a fraction cannot be an integer. So Tanya is incorrect. Zane is correct. Okay. Now, a lot of people just look at this and say they're all negative numbers, which is fine. You could say they're all rational numbers. You could say, what else could you say? Basically, I think that's it. So you could either say that they're all rational numbers, or you can say that they're all negative. I don't see another. Okay, now it wants us to go back to what we were looking at on page 13 and figure out which numbers are between 0 and 1. Okay? And what's the numbers between 0 and 1? I have to get rid of this. This. Okay. 0 and 1. This is 3.14. That's not between 0 and 1. 0.25 would be. Remember how I said the numerator has to be smaller than the denominator? That one is. Nope. This one is 0.20. That one is. This one would come out to be 3, so that one's not. Oh, we could also do, this is a negative number. Negative number. Miss Grandpa totally messed this up because that's a negative number. Negative number, negative number, negative number, negative. Okay, so that's automatically going to go away. This one would be, we said this one comes out to 10, so that one can't be it. This one is. Now, it says between 0 and 1. Okay, I don't know if it means including or not. Usually when it says between, it's not, so that's what I'm going to go with. Okay, some people are like, well, how do I know what the square root of 2 is? So square root means something times itself gets that. So if I took 1 times 1, that would get me 1. This number is bigger than 1, so that means what times itself is going to have to be bigger than 1. This is definitely bigger than 1 because that says 12. That's definitely bigger than 1. This comes out to 16, so that's definitely. This I move over twice and I get 0.005, so yes. The distance from 0, definitely. Numerator is bigger than the denominator. This is 1.5, so that's too big. This negative, so that means this is a really small number. Oops, why did I do that? That one works. This one, what times itself gets 9? 3. Times itself gets 16? 4. So yes. This, I move it over twice and I get 2.12. Nope, bigger than 1. Bigger than 1. What times itself gets 0.25? Well, what times itself gets 25? 5 does. And I need a decimal spot. So that's 0.5, so that's between that. Okay. Then Leslie grouped these numbers together. What could she name this group? Well, we already did this one as 0. Oh, sorry. No, it's not 0 point anything. It's 9.09 with that repeating. This is 2.12. This is 6.25. Okay. I'm not sure if you will know this yet, but these are all rational numbers. How do I know they're rational numbers? Because rational numbers can be a whole number, an integer. I just totally spelled integer wrong. And then it could be a fraction or decimal, as long as that decimal is terminating. That means it ends. Or repeating. Okay. It can also be the square root of a number that is a perfect square. And all of these numbers are under that category. So, negative numbers. This one is the only one that has all negative numbers. Integers, it means positive and negative numbers. No fractions. No decimals. Okay. So I have to look for something that doesn't have any fractions or decimals. Well, this one has a decimal, so that's not it. This one has a decimal, so that means it must be this one right here. Improper fractions. Well, you're probably looking at this going, well, how are either one of these groups improper fractions? Well, 1.5 is 1.5. If I did that, it would be 15 over 10. This one is improper. This would be 2.12 over 10. 612 over 100. So this group are improper fractions. And numbers between -1 and 1. So this is 0.2. This one is 0.3. There we go. And so this would be D.